All right, here we have section 9.1, deals with reflections. So there's our main ideas: draw reflected images, and then recognize and draw lines of symmetry and points of symmetry. And then 5 vocab words: reflection, line of reflection, isometry, line of symmetry, and point of symmetry. So definition-wise, a reflection is a transformation representing a flip in the figure. So if you look at that figure there, line M is the line of reflection, because that's the line about which the shape is mirrored. So your original shape has vertices A, B, D, and E. So A, B, D, and E. And then the reflected are down here, A, B, D, and E. If you notice, the reflections have little apostrophes after them to denote that they are the reflected image. You can also reflect across a point. If you do that, in addition to flipping either, like so for example, this one flips top to bottom. If you reflect about a point, you're flipping top to bottom and front to back. So who knows Y here is in the back top, and now it's reflected to the bottom front. So you've reversed both directions. Now, when you make a reflection, your images are congruent. That means it's a congruence transformation, which is referred to as an isometry. All right, so for example here, triangle KMN has vertices at those given points, and then asks you to do 3 different transformations reflected under the X, reflected under the origin, and reflected across the line Y equals X. So let me grab some graph paper here. So let's see here. We will do, let's see here. So K is at 2, -4. M is at -4, 2. And N is at -3, -4. So there's my triangle. And let's see, we're going to do the x-axis. Okay, so if you reflect across the x-axis, there's the x-axis. So that's going to flip everything top to bottom. So this point down here, that was 1, 2, 3, 4 below, will now be 1, 2, 3, 4 above. It'll be there. This one will be 4 above as well, and this one, instead of being 2 above, will be 2 below. So my reflected shape looks like that. All right, so plot those original points: 2, -4, -4, 2, and -3, -4. All right, so second part of that example said, where's it? Origin. All right, so that's flipping everything over, so that's flipping in both directions. So this one that was 3 left and 4 down will become 3 right and 4 up. So that's that point. This one was 2 right, so it's now going to be 2 left, and it was 4 below, so it's now going to be 1, 2, 3, 4 above. And then this one was 4 left, so it'll now be 4 right. It was 2 up, so it'll now be 2 down. So reflected across the origin. And the last one was the line Y equals X. So 2 -4s down there, -4, 2, and -3, -4. So there's the original shape. Now the line Y equals X actually just means reverse the X and the Y. So the first point was 2, -4, so that's going to be at -4, 2, which I already have a point there, so that'll be right on top. The second point was at -4, 2, so it'll be at 2, -4, which is already right there. And then the last one was at -3, -4, so it's going to become at -4, -3 right there. So the triangles are almost identical, but you just flip the x's and the y values. Okay, so there's example 1. So the next thing you've got is, whoops, skip the page. There we go. So these are just the general rules for the reflections. So they actually give you specific instructions if you don't want to think about how it would look. So x-axis, you multiply the y coordinate by -1. Y-axis, you multiply the x coordinate by -1. The origin, you multiply both coordinates by -1. And the line y equals x, you interchange the x and the y coordinates. So that was the last one we did. So if you have a figure that can be folded exactly in half, so the 2 pieces line up exactly, that fold is a line of symmetry. And then if you can find a common point of symmetry, that's the point of symmetry. So just some pictures. So the letter F, for example, has no lines of symmetry. The isosceles trapezoid has one. You can fold it in half vertically. That rectangle with the arrows coming off of it, you can fold in half in two directions, either top to bottom or left to right. This crazy shape you can fold along any of the spokes. Points of symmetry typically occur where your lines of symmetry meet. All right, so last example here, determine how many lines of symmetry a square has. So I'll draw a real rough square. We'll talk about the number of ways you can fold it. So there's one fold, two folds. You can also fold it corner to corner, three folds, and four folds. So there's 4 lines of symmetry, and there's your point. So for the last one here, a rectangle. How many ways can you fold a rectangle? There's one fold in half there. There's one fold in half there, and that's it. You can't fold the diagonals on a rectangle because then the pieces won't line up. If you take a piece of paper and try to fold it in half corner to corner, it won't work. You won't get the two pieces exactly. The corners that you folded towards each other will not line up. And that's the end of section 9.1.